All right, now we're going to have a look at 13b, which is the sine rule. Oops. 13b. And this is on page 393. So trigonometric ratios are really useful when we've got a right angle triangle, but we're not always going to have a right angle triangle. So let's draw one that's non-right angled. And I'm going to label this A, B, C. So my corners are capital letters. And then my sides, they're opposite their matching corner. So if that's capital letter A for the angle, this is small lowercase letter a for the side. Similarly for B, lowercase b is opposite B, and lowercase c is opposite C. And the sine rule tells us that if we do A over sine A, that's the same as B over sine B, or C over sine C. So we only ever use two of these at once, because usually we'll have three bits of information, and then the fourth one gets left as the thing we want to find. So let's do some examples. I'm going to choose 1b. That's not one that you do. And it looks like this. And we've got x, y, z and y. So this is lowercase y, opposite y. This is 65 and this is 37. And we want to find the value of the pronumeral. So in this case, the y. So because they always go with their matching angle, y on sine 37 is going to be the same as, oh, let's look, we've got a little bit of extra. That's in the question, tells us that's 6 centimetres. So y on 37 is the same as 6 on sine 65. So if you like, here you can write in solve, comma, y, and get your calculator to do it for you. Sometimes it's just as easy to go 6 times sine 37 divided by sine 65. And if we work that out, we get 3.98, I believe. If you don't get 3.98 when you do it, it's probably because your calculator's not in degrees. The calculator defaults to radians, so you need to go back into your settings, set your document settings to degrees, then make default to make sure that that works, otherwise you'll get them all wrong. Let's have a look at 2b. And in 2b, the difference is here we've got to find an angle. So I'm going to draw this example. We've got A, C, B, 9.4, 8.3, and we need to find this angle, theta. So what do? I choose the matching side. So I go 8.3 over sine theta equals 9.4 over sine of 42, because if you go and look in the question, I've forgotten again, that's 42, that's already given. So what I could do here is, instead of writing theta on my calculator, I'll probably write x, because that's easier than finding the theta symbol. If you type into your calculator to solve this for theta, it gives you this big crazy amount of solutions. So what you can do, if you want to use it on your calculator using solve, you have to go solve that for, and I'm going to make this x. And then you have to restrict the domain between 0 and whatever. In this case, we'll say 90. That's a bit of a pain. What it's easy to do is say, if we've got 8.3 on sine x, 9.4 on sine 42, let's flip the whole thing over and make it sine x on 8.3 equals sine 42 on 9.4. And that way we can just say sine x equals 8.3 times sine 42 on 9.4. So to find x, we'll go, it's the inverse sine of, and then we'll write that in there. And if you do that, you should get 36.22 degrees. Again, if you're not getting it, make sure you're in degrees. Make sure your order of operations is okay. So that is the sine rule. As you go through, some of the examples are a little bit harder. If you get to some that you can't do, look up the work solutions. If it's still not giving you any joy, just let me know and we can go through it together. So that's 13b, the sine rule. You can go and do those questions now.